Hello, my name is Dariu Gavrila, and this is an overview of my research on active vulnerable road user safety in the past 20 years. About 1.2 million people are killed yearly in traffic worldwide. More than half of these are vulnerable road users, pedestrians, cyclists, and other riders. It would be a great benefit to society to have an AI system that could reliably detect dangerous traffic situations ahead of time, in order to warn a driver or automatically perform evasive maneuvering. When I started working on this topic in '98, half of my colleagues said it cannot be done because of technical difficulties, and pretty much the other half said it is not needed because customers buying a car would not want to pay extra for the safety of those outside the car. But I pursued the matter nevertheless, and since processing power and training data was a real bottleneck back then, I developed a method for efficient shape-based object detection using a hierarchical matching approach. We furthermore developed an architecture for efficient multi-queue pedestrian detection, which involved region of interest generation by sparse stereo, hierarchical shape-based detection, and a verification step by a convolutional neural network, followed by modules for tracking, situation analysis, acoustical driver warning, and automatic braking. Frankly, our first generation system performed quite poorly. There were many false positives, false negatives, and one test person, when asked about the system, said what she liked most was the engine of our vehicle. It allowed for such a smooth acceleration. We performed pre-crash tests with real vehicles and pedestrian dummies. Conversely, we performed pre-crash tests with dummy vehicles and real pedestrians. The latter was a first and allowed us to collect very rare, realistic pre-crash footage. Our second generation system performed a lot better, driven by faster processors, more training data, and better algorithms. Meanwhile, we were performing region of interest generation by dense stereo and initial pruning by the Hawk method that had recently been introduced. Also, a worldwide first was our integrated system, which demonstrated active pedestrian safety by evasive steering. After many years of improving pedestrian detection performance, we were gratified to see our system commercialized in a Mercedes-Benz C, E, and S-Class models introduced in 2013-2014.
A car that can actually see like a human, using stereoscopic cameras, and even stop itself if it has to. The technology may be hard to imagine, but why you would want it is not.
Accident analysis showed that the system would be beneficial to traffic safety. At the same time, its main limitation was that it would wait till the very last moment before reacting, when the pedestrian would already be in the vehicle driving corridor. If we could better anticipate what the pedestrian would do, we would save valuable time to react. So my attention shifted from the detection problem to the path prediction problem, and in 2011 we published what I believe to be the first paper on vulnerable road user path prediction at a German pattern recognition conference where it won a prize. Whereas our early system used low-level image features like optical flow for path prediction, our later approaches involved higher-level features such as head and torso orientation. We integrated these cues in a context-based switcher linear dynamical system approach using a Bayesian network. In demonstrations, we showed that this approach gained up to 1 second in reaction time without increasing the false alarms. The approach is generic and applies to other traffic scenarios and road users as well. Along the years, we made a number of annotated image datasets available to the scientific community for benchmarking. The most recent addition is the EuroCity person dataset, which brings VRU detection benchmarking to a new level in terms of quantity, diversity, and detail. We have come a long way regarding active vulnerable road user safety in the past 20 years. But more research needs to be done before the self-driving car can survive and thrive in a complex urban environment, full of VRUs not always behaving equally forthcoming. So the past has been wonderful, but the best is yet to come. Thank you for your attention, and credit to my former and current PhD students that have strongly contributed to this research.